Good morning, everyone. Our topic is all about Kruskal algorithm spanning tree under the leadership of Ricardo Viloria and his members, Willie Katingan, John Leonard de Saraga, Jeline Liza, Cheryl Guancia, and Aris Gajano.
Step 2. Arrange all edges in their increasing order of weight. The next step is to create a set of edges in weight and arrange them in an ascending order of weight cost. Step 3. Now we start adding edges to the graph beginning from the one which has the last weight. Throughout, we shall keep checking that the spanning properties remain intact in case by adding one edge the spanning tree property does not hold, then we shall consider not to include the edge in the graph. The last cause is 2 and edges involved are BD and DT. We add them. Adding them does not violate spanning tree properties, so we continue to our next edge selection. Next cause is 3 and associated edges are AC and CD. We add them again.
Good day, everyone. I'm Cheryl Guancia. We'll continue the topic under Kruskal algorithm minimum spanning tree, which is data structure and algorithm spanning tree. What do we mean by data structure? One sentence description of this is different ways of storing data on your computer. What about algorithms? They are the operations that we can perform on different data structure and the sets of instructions for executing them. So, data structure and algorithm spanning tree. A spanning tree is a subset of graph G which has all the vertices covered with minimum possible number of edges. Hence, a spanning tree does not have cycles and it cannot be disconnected. Under that, we have graph G, wherein A, B, and C are all connected, where A is connected to B and B is connected to C and C is connected to A, and so on and so forth. Under graph G, we have spanning trees, wherein A is connected to B and B is connected to C. Second one is A is connected to C and A is connected to B. Last is A is connected to C and C is connected to B. It has one part that is not connected. So we found three spanning trees of one complete graph. A complete undirected graph can have maximum n-2 number of spanning trees, where n is the number of nodes. In the above addressed example, n is 3, hence 33 minus 2 is equals to 3. Spanning tree is possible. So what do we mean by node? By the way, it is a point at which lines or pathways intersect, or it is a central or connecting point.
Good morning, everyone. My name is Jeline Liza. Today I will discuss to you the general properties of spanning tree. We now understand that one graph can have more than one spanning tree. Following are a few properties of spanning tree connected to graph G. A connected graph G can have more than one spanning tree. All possible spanning tree of graph G have the same numbers of edges and vertices. The spanning tree does not have any cycle, loops. Removing one edge from the spanning tree will make the graph disconnected. The spanning tree is minimally connected. Adding one edge to the spanning tree will create a circuit or loop. The spanning tree is maximally acyclic. Mathematical properties of spanning tree. Spanning tree has n-1 edge, where n is the number of nodes, vertices. From a complete graph, by removing maximum e minus n plus 1 edges, we can construct a spanning tree. Thus, we can conclude that spanning trees are a subset of connected graph G, and disconnected graphs do not have spanning trees.
Good day, I'm Aris Kijano from BSCS 2A. Today I will discuss you the application of spanning tree. Spanning tree is basically used to find minimum path to connect all nodes in a graph. Common application of spanning tree are civil network planning. Network planning and design is an iterative process encompassing topological design, network synthesis, and network realization, and is aimed at ensuring that a new telecommunication network or a service meets the needs of the subscriber and operator. Computer Network Routing Protocol. A routed protocol is used to deliver application traffic. It provides appropriate addressing information in its internet layer or network layer to allow packet to be forwarded from one network to another. Example of routed protocols are the Internet Protocol or IP and Internet Package Exchange or IPX. Cluster analysis. Cluster analysis or clustering is the task of grouping a set of objects in such a way that objects is the same group called cluster. Let us understand this through a small example. This city network has a huge graph and now plans to deploy telephone lines in such a way. In minimum lines, we can connect to all city nodes. This is where the spanning tree comes into picture.